What are acid, base and salt? Now you have seen acid, but then whenever acid comes into our mind, so you people think about that acid which is there inside the battery. The acid which is there inside the battery is sulfuric acid, but it doesn't mean that sulfuric acid is the only acid. There are hundreds of acids. For example, some of the very common acid may be consumed, we consume it. For example, anything which is a sour fruits like oranges, contain citric acid. Then lactic acid present in milk. Then you might have heard about boric acid, boric powder, which is used as an antiseptic. That is also an acid. Then you have hydrochloric acid, nitric acid, carbonic acid. Carbonic acid is in fact an acid present there in your cold drinks. So carbureted drinks, we call that, in fact, when carbon dioxide is mixed with water, it becomes carbonic acid. Now these are all acid. Bases. Now bases may not be very common for us, like we might not have come across bases, but then we use in our day-to-day life many bases we use, but then you may not realize that it is a base. So one base which you cannot do with is soap. The soap that you are using is a base, but in addition to that there are so many other bases that we use. Now as we reach there, you will understand what exactly that base is. And usually acid and base are taken as opposite. Now if you really talk about acid and base, what are acids? In physically, if you talk about acids are usually liquids, but it doesn't mean that all acids are liquids, because there are also acids which are solid. For example, I said about boric acid, oxalic acid, they are solid. So acid can be solid also. So they are usually solids and liquids. And same thing can also be said with bases. Bases also can be liquids. For example, sodium hydroxide, the most common base, is a liquid. And there are so many other bases, like for example, if I am talking about copper oxide, which is also a base, but it is a solid. So it can also be a liquid and a solid. Then if acids are sour to test, now if you are testing, they are sour, but it doesn't mean that acid should be tested. If sulfuric acid, if you test, then they are very corrosive, dangerous, should not be tested. TASTE, I mean not TEST, tested with your tongue. But acid should not be tested. But if you are testing, for example, acids like lactic acid, citric acid, when you test, they are sour, and all acids are sour. Whereas bases are bitter. They are very bitter. If you by mistake, if you have tested the soap when you are taking bath, or maybe a shampoo, a little bit, or maybe when you are opening a pouch of shampoo, a little bit of shampoo, if it is going into your mouth, then you know what it tastes like. So it is very bitter to test. And yes, this is also soapy to touch. Soapy means they are usually slippery. Most of the bases are very slippery to touch. So they are soapy to touch, bitter and soapy. Whereas this is what is sour and corrosive. Corrosive means can be dangerous. It can cause some harm to your skin. So that is what is corrosive. So let me write down corrosive. They are corrosive. So soapy. Now a compound, if it is not an acid and a base, then it is a salt. Okay, now if you say salt, then you may be knowing only one salt. Salt is the salt that we consume, in the salt which is put into our curry. So that is sodium chloride. But in addition to sodium chloride, there are thousands of salts. But you may not be knowing that for us salt means only that salt which you consume at home. So that is not the only salt. There are, as I said, hundreds of salt. So that is why, like for example, if I tell you one, so here sodium chloride. And salts are also usually, they are solid. By the way, they are usually solid. Most of the salts are solid. Now when we talk about acid, base and salt, now what is the proper way in which you can recognize an acid, base and salt? Now I'll give you a simple technique of remembering what is acid, base or salt. How to recognize? By looking at a formula. Now if I am writing one formula, how do you recognize whether it is an acid or a base? Okay, now see the simple technique. Our every compound, whether it is acid, base or salt, is consisting of two parts, the cationic part and the anionic part, like this, the cationic part and the anionic part. So X I am taking as cationic part and Y as anionic part. Okay, this is the cationic part and this is what is the anionic part, meaning positive radical and negative radical. So in the first chapter also I discussed about that valency table, positive valency table, negative valency table. You are going to find this, like for example sodium you are going to find here, sodium you are going to find here, chloride you are going to find in the negative valency table. So that means by looking at this cation and anion for any compound, you will be able to say whether that given compound is acid, base or salt. Okay, then here it's I am making a chart. Cation and an anion. Okay, if a compound is an acid, and every time the cationic part of an acid will be hydrogen ion. So if cation is hydrogen, the anion can be anything. Now let me tell you now what do you mean by that cationic hydrogen. Anion can be anything other than OH. Only OH should not be there, or else if H and OH is there, then it becomes water, and water is not acid. So that's why if H plus, now look at this, if cationic part and anionic part, if I am talking about, if this is H and anion part, if it is Cl, then HCl, hydrochloric acid, you can see cationic part, hydrogen is there. Similarly sulfuric acid, H2SO4, there cationic part, hydrogen is there. Then anion, again if I am going for something else, HNO3 or carbonic acid. So there nitric acid, carbonic acid, that means every acid has in it hydrogen. Now we may face a small problem with the organic acid. For example, if I am writing organic acid, CH3COOH, this is what is acetic acid. Now you may say, sir, where is hydrogen? And then you said cationic. Now you may think that this is cationic. But in this organic acid, you know, anion is what is written first. This is anion, acetate. In the valency table, you are learning acetate down, anion. So that's why we write anion first, and cation is what is written second. So that's why you can see still cation is hydrogen. So cation part is still hydrogen, that positive part is still hydrogen. So this is how you recognize an acid. So when I am writing a formula of an acid, you look for hydrogen, because hydrogen happens to be an integral part of all acid. Without hydrogen, there is no acid. So that's why if you see the formula of an acid, every acid must contain hydrogen. This is how you recognize an acid. Then how do you recognize a base? In a base, now the cationic part and the anionic part. Cation must be any metal, so many metals, you know, that means now I should tell you anything which is there on the upper part of your valency table. The upper part of your valency table contains so many different metals. So metal, or if not metal, then one more I think I should add, and that is ammonium. Either metal or ammonium must be present in the cationic part. So there in the cationic part, ammonium, for example, metal, let's talk about sodium, metal. Now what should be the anion? Anion should be either oxides or hydroxide. Okay, here, so Na, if I write oxide or a hydroxide, so oxide or hydroxide, so Na and OH, metal and hydroxide. Metallic hydroxide is a base. Metallic oxide is a base. Ammonium hydroxide is also a base. Ammonium oxide, as such, there is no compound called ammonium oxide, so that's why ammonium hydroxide. So ammonium, so combine this. Metal oxide is a base, metal hydroxide is a base, ammonium oxide, no compound, ammonium hydroxide bases. So that means a metallic hydroxide or a metallic oxide, including ammonium hydroxide, they are bases. So in the cation part, if a metal is present, and in the anion part, if oxides and hydroxides are present, then we say they are bases. Okay, now if you see some example of bases, here it is sodium hydroxide, the most common base, potassium hydroxide. Now it doesn't mean only hydroxide, it can be oxide also. Here copper oxide is a base, sodium oxide is also a base, sodium oxide. So metallic oxides and metallic hydroxides, even ammonium. Now if I am going for ammonium, here it is, ammonium hydroxide is also a base. So this is how you will recognize a base. Then salt. Usually for a combination of salt, okay, if this is XY salt, this part, the cation of a salt is borrowed from a base. So cation is borrowed from a base and anion is borrowed from an acid. Meaning this cationic part of a base will be present there in the salt. Whereas here anionic part of an acid is what is, yes, it is written anything other than hydroxide, and I should tell you anything other than oxides and hydroxide. Okay, I better, here it is written only hydroxide, but I should say anything which is should not contain oxides and hydroxide, anything other than oxides and hydroxide, because if it is oxide and hydroxide it becomes a base, because cation part is same. So that's why anything, now when I say anything, don't forget in your valency table, especially the negative valency table, there are so many anions, so many on the lower part of the valency table, so many anions are present, and out of so many only exclude oxide and hydroxide. If any other, now when I say any other, carbonate, dichromate, so many are there, to just name a few. You have sulfide, bisulfide, sulfate, nitrite, phosphate, so many. So that means anything which is odd but should not be oxide and hydroxide. Now see here, what I'll do, I'll borrow one metal from base. Okay, let's borrow a metal, sodium. Okay, I borrowed. Then let me borrow anything other than oxide and hydroxide. Anything other than oxide and hydroxide is carbonate. Here it is, sodium carbonate. So sodium carbonate becomes a salt. Similarly, if I am going for ammonium, if I am borrowing ammonium from base, the cationic part from the base, then the anionic part, anything other than oxide and hydroxide. So anything other than oxides and hydroxide. So then I may write ammonium sulfate. Here it is, ammonium sulfate is a salt. Now if I am borrowing one metal from here, copper, so one metal will be here. Then other than oxide and hydroxide, so many are there. So if I am writing a sulfate or a chloride or a nitrate, whatever you like, you can write. Let me write down nitrate here. So copper nitrate. So it doesn't mean that sodium chloride only is salt. See, I did not write even sodium chloride as an example. Sodium chloride is not the only salt. There are, as I said, thousands of salts. So this is how actually you will recognize. So if I write a formula of one compound, then immediately by looking at it, whether it is an acid or whether it is a base or it is a salt. See, just follow this chart, a simple table which will help you to recognize whether a given substance is acid. Again I am repeating, for an acid, hydrogen is a must. Without hydrogen is not an acid. For a base, it should be metallic oxide, metallic hydroxide or ammonium hydroxide, that is base. And for a salt, same thing, metal or ammonium should be present in the cation, and in the anion, anything which is other than oxides and hydroxide, then it becomes a salt. Yeah, this is how you will recognize an acid, base and a salt. In fact, now your total detailed study about this acid, base and salt is what is based on this. So every time whenever I say an acid, don't forget what is the meaning of that, what is necessary for an acid, and when I say a base, what does it mean, or when I say a salt, what does it mean. Yeah, since the chapter is very lengthy, so I'll not be able to finish it in one go. So maybe I'll divide this into part, maybe 2 part or 3 part, and I'll finish it off. So now today I'm going to start with, so this was just an introduction about recognizing acid and base. Now I'll move on to recognizing, the detailed study about acid. So first I'll discuss acid, then after that I'll go to base, and finally I'll be discussing salt. Now, what is an acid? Acid are chemical compounds which when dissolved in water, so that means acids are compounds which when you dissolve in water produces only one type of cation, only one kind of positive ion, and that positive ion should be hydronium ion. So in second chapter we discussed about the formation of hydronium ion, H3O plus. Now what is the meaning of this? Okay, you all know what is the meaning of hydronium, H3O plus. We have seen already about the formation of hydronium ion in the previous chapter, in chemical bonding chapter, how hydronium ion was formed, a coordinate bond or a dative bond was what was associated with hydronium ion. This acid, an acid is considered an acid if when you are dissolving it in water, it should produce only one type of cation, and that type of cation should be hydronium ion. Again I am repeating, and then the type of cation which should be produced should be your hydronium ion. If any other cations are present or positive ions are present other than hydronium ion, then you can't consider that as an acid. Okay, now see then what I said about the definition. Again I am repeating, listen it again, rewind it and see it again. Acids are chemical compounds which when dissolved in water produce hydronium ion as the only cation, or if you don't want to say as the only cation, then you can say as the only positive ions. Meaning, yeah, if HCl is an acid, then if you are dissolving this in water, So if you are dissolving this in water, this hydrogen should go and actually join with water to form here hydronium ion. So you can see hydronium ion is produced. At the same time, chloride ion. So only one positive ion is produced, only one kind of positive ion is produced, and that is, and now see, I am saying one kind, it's not one number. This hydronium ion, plenty, millions of hydronium ion will be produced, but all of them are hydronium ion, only one kind of positive ion. Yes, negative ion, it really doesn't matter how many negative ions may be produced, there might be more than one negative ion, but then positive ion, only one should be there, and it has to be this hydronium ion. That means every acid is associated with hydronium ion. As I said in the beginning, in the formula, hydrogen should be present in acid. That very hydrogen, when it comes in contact with water, when you are dissolving it in water, it forms hydronium ion. So that means every acid must be recognized by this hydronium ion. So this is what your acid is. Now, if I go to the next topic now about acid, then we'll classify acid now. I'll have a very short description or discussion about this classification of acid. Acid may be classified under different headings. Now see, what are the different headings? First classification is acid may be classified according to its origin, from where we are deriving it. Yeah, they may be derived from plants or animals, and usually it is plant, or they may be derived from minerals. Mineral means chemicals found under the ground, under the earth crust. Those acids which are derived from plants, directly or indirectly, it may also be from animal, even though it is not a proper definition. You will see in organic chemistry that all organic acid does or compound doesn't mean that plants, animals, even though this is an older definition. But as of now, we'll discuss our first kind of acid as those which are derived from plant. They are called organic acid. Okay, for example, many organic acids that you know, acetic acid, or let's call it as citric acid that we discuss about. They are all something which has been derived from plants. Yeah, even though there are many which are derived from animal, for example, lactic acid that we discuss about, many of the other different acids which are there are directly or indirectly associated with plants or animal. Such acids are called organic acid. Whereas those which are derived from mineral, no association with plants, animal, they are called inorganic acid. Now in inorganic acid, most of the acid that we know, they are inorganic, like for example your sulfuric acid, hydrochloric acid, nitric acid, you know, they are all inorganic acid. Inorganic acid, whereas organic acid, as I told you, the most common one is acetic acid, or it can also be your lactic acid, citric acid, so many are, oxalic acid, boric acid, they are all organic acid. So this is the first classification. Second one, acid may be classified according to its, this is important now, basicity. Now what is the meaning of basicity of an, even though we are discussing about acid, but we are discussing here basicity, because for acid we say basicity, and later on you will see that for base we say acidity. Basicity is defined as the number of hydrogen ion produced when one molecule of the acid ionize. Ionize means breaking into ions. That also we saw in our previous chapter in chemical bonding, ionization and dissociation. So whenever an acid, okay, for example, when HCl is dissociating, breaking into ions, here it forms H plus and Cl minus. You can see one molecule of HCl is producing only one. So then we say the basicity of hydrochloric acid is 1, or we say it is a monobasic acid. Mono means one. Monobasic acid, HCl is a mono, because for one molecule it is giving only one. Whereas if I am talking about sulfuric acid, when sulfuric acid will break, it will also give you H plus and sulfate ion. But if I have to balance the equation, then two hydrogen are there, so I have to write here 2. So that means for one molecule of sulfuric acid, it is giving you 2 hydrogen ion. Then we say basicity of sulfuric acid is 2. Or we say it is a dibasic acid. Sulfuric acid is a dibasic. Di means 2. Similarly, if I am going on to the third acid, phosphoric acid. This is phosphoric acid. You know, phosphate valency 3 has come here. So when this breaks into ion, it also gives hydrogen ion and phosphate ion. But then to balance it, I have to write here 3. So for one molecule of phosphoric acid is giving you 3 hydrogen ion. So that's why we say the basicity of phosphoric acid is 3. Now you must be wondering that by just looking at the number of hydrogen in an acid, we can say what is the basicity. Yes, it's very true, but it does not always work, especially with respect to organic acid. Now I'll show you. Okay, let me take this one, CH3COH. This is acetic acid, organic acid. Now if you look at the number of hydrogen here, 3 here, here 1, 4. So total number of hydrogen present 4. So that means you may say, sir, yes, the basicity of this acetic acid is 4. But then I'll say it's not true. Even though 4 hydrogen are present, but how many hydrogen ions are ionizable? Ionizable means it gets separated into positive ion, hydrogen ion. For acetic acid to ionize, when it ionizes, it gives you H plus. So this part you can see is H plus, and this rest part will become acetate, CH3COO. You know this acetate. So acetate, this hydrogen, 3 hydrogen has gone in acetate, the negative ion, but only 1 hydrogen. So even though 4 hydrogen were here when you count, but only 1 hydrogen was ionizable. It was getting ionized, only 1 hydrogen. So for 1 molecule, only 1. So sometime the question may be asked, what is the basicity of acetic acid? Then don't count 4 and say 4. Acetic acid, only 1 hydrogen ion is replaceable. So that is why the basicity of acetic acid is 1, or we say it is a monobasic acid. So this is what is your second classification of acid. Now third one, you can consider it as a classification, at the same time also a very very important thing, especially the third one and the fourth one, which I am going to discuss. These are concentration. Now acid may be discussed as or described as what is concentrated acid, and the other one is dilute acid. So this is to do with quantity of water and acid. So if the quantity of water is more, then we say it is dilute, and if the quantity of acid, if it is more, then we say it concentrated acid. Okay, for example here, if acid is more but water quantity is less, then we say the acid is concentrated. That means more acid, less of water. Whereas just the opposite, if the acid quantity is less but if water quantity is more, then we say that the acid is a dilute acid. So that means a concentrated acid can be made into a dilute acid by simply adding water. So here quantity of water is very less. Add plenty of water to concentrated acid, it becomes a dilute acid. Almost like you have a very pure milk. A milkman has given you very pure milk. Now, so then we say it is a concentrated milk. Then if you want to make it dilute, add a lot of water, then it becomes a dilute milk. So acid also same. If quantity of water is less, it is concentrated acid, and if the quantity of water is more, then we say dilute. That's why you might have heard about concentrated sulfuric acid, dilute sulfuric acid. So it is all something to do with concentration of or quantity of water. Now the last one, let me discuss it here, is strength. Now in terms of the strength, an acid may be a strong acid or it may be a weak acid. Now this, do not get confused between concentration and strength. Concentration is something to do with water quantity. Strength is something to do with hydronium ion, quantity, number of hydronium ion. So if an acid when dissolved in water produces plenty of hydronium ion, a large number of hydronium ion is produced, then we say the acid is a strong acid. But when that acid is undergoing ionization or breaking, if it produces very less number of hydronium ion, then we say then that acid is what it can be termed as a weak acid. Now for example, HCl is a strong acid because when HCl is dissolved in water, it produces plenty of, now here dissolved in water means it produces plenty of hydronium ion. So the quantity of hydronium ion which is produced here is very large, so we say strong acid. Whereas acetic acid is a weak acid. Why acetic acid is a weak acid? Even though it is dissolved in water, it produces hydronium ion, but the number of hydronium ion produced will be very less. Number, here I am talking about number, I am not talking about volume. So the number of hydronium ion produced will be less. So we say it is a weak acid. Carbonic acid is a weak acid, acetic acid is a weak acid. Most of the organic acids are weak acid because the number of hydronium ion produced is very less whenever they are dissolved in water. This is what is about your classification of acid.